Welcome to Spring LIB.
All right, so in this problem, we have a circuit. Let me draw it for you. So we have this C1, and this is a battery, and we have this branch here, and there's another one, and another one here, right? And there is another loop over here. Okay, let me see. Yeah, this is C2. So we know that the battery has voltage V equal to 10 volts, and each capacitor has capacitance C equal to 10 microfarads. So the question is we want to find out the charge stored on C1 and C2. So if we look at C1, this is pretty simple because as you can see that for C1, the bottom side just connected to the positive side of the battery, and the top side just connected to the negative side of the battery. So the potential difference of C1 is simply equal to V, which is 10 volts, right? So we can find the charge stored on C1 very easily. So Q1 equal to V1 times C1, which is 100 microcoulombs. But for C2, we need to find out the voltage distribution on the capacitors. So firstly, we can see that this capacitor is in series of this whole bunch, right? So firstly, we need to find out the capacitance of this part. This part contains a parallel connected part. So this one is in parallel with these two, right? So, and these two, of course, they're in series because they all have the same capacitance, which equal to 10 microfarads. So these two has a total capacitance, let's say C2, uh, C2, anyway, C2 prime equal to just equal to half of C2 because these two, they are in series, right? So equal to 5 microfarads. And these two, actually, they are parallel with this one. So basically, let's see, C2 prime prime equal to C2 prime plus 10 microfarads, which equal to 15 microfarads. So this is the total capacitance of this whole part. And then this whole part is in series with this one. So we can find out the voltage distribution of this whole part. Let's say this is just equal to V2 prime prime, which equal to C2 prime prime plus 10 microfarads. So this 10 microfarads comes from this one, okay? And the numerator will be 10 microfarads. So we have the value for C2 prime prime and times V, times V. So V is 10 volts, so this gives you 4 volts. So this is the voltage. This is the potential drop of these 2 points from this point to this point. So basically, we can find out the voltage drop across C2 now, because C2 has the same capacitance as this one. So basically, the voltage drop across C2 just equal to V2 equal to half of V2 prime prime, right? Equal to 2 volts. Then we can find out the charge stored on C2 now. So Q2 equal to V2 times C2. C2 is 10, so this is equal to 20 microcoulombs. Okay.